Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to talk about higher order constructs, reflective formative model. Now, let us try to understand what is the concept of second order components or a higher order components, also known as a hierarchical component models. Price is captured with the help of some measured variable. Service quality is captured with the help of some measured variables. Personnel is captured with help of some measured variables, and service cap is captured with the help of some measured variables. So price, service quality, personnel, service cap, they are all constructs. Now, price, service quality, personnel, service cap, all these constructs combine together to form the higher order construct, and that is a satisfaction. So satisfaction is combination of all these constructs. So here the satisfaction is considered to be the second order components, and price, service quality, personnel, service cap, they are considered to be the first order components. Now, depending upon the arrows coming inside the construct or going outside the construct, depending upon are the statements causes or consequences, we can have four type of models. Normally, the nomenclature goes this way, that the first we write for the lower order, that is, it is reflective or formative for lower order, and then for the higher order. If we start with the type 1 model, you can see all the arrows are moving out of the construct, and therefore it is a reflective model. You can see the same case for the higher order also, the arrows are moving outside, and therefore it's a reflective model, type 1 model. This model I have already discussed in my earlier videos. Please refer my previous videos to understand the flow of this entire lecture series. If I talk about type 2 model, in lower order, the arrows are moving out, and in higher order, arrows are moving inside the construct. And therefore, it's a reflective formative model. It's a type 2 model, which we are going to discuss now. If I talk about type 3, in the lower order, all the arrows are moving inside the construct, and therefore it is a formative. If I talk about the higher order, arrows are moving outside, and therefore it's a reflective, type 3 model. In case of type 4, in lower order or higher order, arrows are moving inside, and therefore it is a formative model. So today we are going to discuss type 2 model. So what's a reflective formative? When lower order construct is reflective and then higher order construct is formative. In case of higher order construct, first we will have to report reliability and validity of all lower order constructs. Then we will report reliability and validity of higher order constructs. So let us go into the SmartPLS. Here, the model is job satisfaction is affecting the staying intention of an employee. Environmental perception is affecting the staying intention of an employee. Organizational commitment is affecting staying intention of an employee. Co-workers, behavior of the co-workers is affecting the staying intention of an employee. Now, let us assume that there is a higher order construct, which is a combination of job satisfaction, environmental perception, and organizational commitment. It's just in our assumption that there exists a HOC, higher order construct. So first of all, I'll bring this here. I'll change its measured variable. I'll take it down. I'll delete this. 1, 2, 3. I'll introduce a latent variable here, and I'll name it as HOC, a higher order construct. I'll connect the path. So here I'll connect the path like this. Arrows are moving inside. Why? Let us understand. We are doing type 2 model. And in type 2 model, in lower order, arrows will be moving out, and in higher order, the arrows will be moving inside the construct. Is it same thing? Yes. In job satisfaction, arrows are moving out. Environmental perception, arrows are moving out. In organizational commitment, arrows are moving out. But for higher order, the arrows are moving inside. And therefore, type 2 model, reflective formative model. Let us connect this. Now you can see here that here HOC is in red. This means that the latent variable has no indicators. Now to indicate that this is a higher order construct, what we will have to do? We will have to load the measured variable of all lower order on the higher order. So we'll start with JS1, JS2, JS3, JS4. I'll load it here. Then I'll load EP1 to EP4, EP1, EP2, EP3, EP4. I'll load it. Then I'll load OC1 to OC4, OC1, OC2, OC3, OC4. I'll load it here. You should remember one thing, that the direction of these arrows should be in the same direction for the lower order. So here GS1, GS4, it's a reflective, and here in the higher order also it should be reflective. EP1 to EP4, it's a reflective. So here also it should be reflective. Arrow should be moving out. Now what's the wrong thing? Say for example, if I invert them, now here you can see this is the formative, but the measured variable in the lower order, they are reflective. So this is not permissible. You have to keep the arrows in the same direction. Now, what is the first thing which you have to do? The first thing is you will have to test the reliability and validity of all lower order constructs, such as job satisfaction, organizational commitment, environmental perception, co-workers, and staying intention. As their reflective construct, we will be using average variance extracted, composite reliability, Cronbach alpha for reliability testing, and Forner-Larkin criteria and heterotrait-monotrait ratio for validity. Now let's see how we can do this in SmartPLS. So we'll first check the reliability and validity of all lower order. 1, 2, 3, 4, 5. So now we will run the PLS algorithm. Calculate PLS SAM algorithm. Start the calculation. You have got the results. Open the report. First thing which you should see is outer loadings matrix. The values of HOC you have to completely ignore at this stage because we are testing the reliability and the validity of all lower orders. So you can see here AC1 to AC4, EP1 to EP4, JS1 to JS4, and OC1 to OC4, and SI1 to SI4. As they are all green, it means that the values are more than 0.708, or in other words, the variance extracted is more than 50%. So outer loadings are clear. Next thing which you check is construct reliability and validity. You will go in overview. Again, here also you will completely ignore HOC. Why? What is the reason why we are ignoring HOC? Why we don't consider the value of HOC? I will explain later on. So you have to see the Cronbach alpha, composite reliability, A and C, average variance extracted of all other constructs. Threshold limits for Cronbach alpha is that this value should be more than 0.7, composite reliability more than 0.7, average variance extracted should be more than 0.5. All of them are green, quite good. We'll click on bar chart and you will get the same results. Again, HOC value is ignored. Composite reliability, you can see. Similarly, average variance extracted. Now, we will have to check the discriminant validity. So I'll click here, discriminant validity. Again, I will have to ignore this HOC. I'll have to ignore the values of HOC. First thing which you should do is click on Forner-Larkin criteria. Now, I'll copy these results in Excel. So I've copied the results in Excel. First thing you should do is delete HOC from here and delete HOC from here also. Now, whatever the construct is, it has not generated the results of co-workers. Let's try to figure out. We'll go in co-workers, and yes, it has taken a formative scale. I'll invert this. I'll again go and open the report, and then I'll see discriminant validity, Forner-Larkin criterion. Yes, the results are ready. So it is 0.871. I'll just quickly write it down, 0.871. Now, how to interpret these results? Diagonally, these values which are there, these values should be maximum in corresponding rows and columns. So if you can see, for job satisfaction, is 0.799 maximum in corresponding column? Yes. Corresponding row, is it maximum? Yes. This means that we have achieved the discriminant validity. Okay. The next thing which you should see is heterotrait monotrait ratio. Again, we'll have to ignore the value of HOC. Here, the heterotrait monotrait ratio, the threshold limit is this value should not be more than 0.85. And in most of the cases, we are getting it less than 0.85, and therefore we have achieved the discriminant validity. So reliability and validity achieved of the lower order. But what about the higher order? And why we are not considering these values which are already there of HOC? Let's try to understand what's wrong. The software will generate the values of reliability and validity on the basis of these values. That's this lower or the measured variables of the lower order. But actually, if I want the reliability and validity of HOC, it should be based on 1, 2, 3. Okay. So we will have to save this data, and we'll have to generate the reliability and validity in the second stage. Also check the collinearity statistics. These values should be less than 3 for outer model as well as the inner model. You can see all the values are less than 3. If you see the collinearity statistics of HOC, it will be almost equal to 1, which is completely wrong. Now what I'll do, I'll save this data file. So I'll go and create data file and make sure to have a tick on manifest variable scores and latent variable scores. The latent variable scores works as a proxy for the constructs. And the latent variable score is a one composite score per construct. If you want to include the measurement model in your analysis, you should also consider the manifested variable. So we will have to transfer this manifested variable to the raw data file. So basically, I want to incorporate latent variable scores and manifest variable scores in the raw data. The new features of SmartPLS are really cool. You can do it directly. The file will be saved with this name HPAT SAM1 derived from PLS results. Press create. Now you can go back and you can select the data set from here. At present, in the original raw data file, you will not see any latent variable scores. But as soon as you switch the data set, your latent variable scores are visible. Now you can see one thing here, that HOC, the R square of higher order construct is 1. The reason is that all the lower order constructs which are there, JS1 to OC4, they have been considered for higher order. Now, if you run the same thing, that is a dependent and independent variables are same, naturally HOC will be taking the value of 1. Now what will happen is, it will not allow other path coefficients to take any variance. And therefore, this is a flaw in this design. So to overcome this, in the previous versions, we used to have the extended approaches. But here, things have been made very simple. How we can run HOC for formative scale, let us understand. First of all, let me remove this entire thing. Now I will say that my HOC, I'll take the latent variable scores directly. Job satisfaction, organizational commitment, environmental perception, directly I'll drag it and drop it here. Enter. I'll rename this as HOC. At present, the model is reflective. We'll have to invert the model. I am not able to see the names here. I'll click on it. So I'll say this is environmental perception latent score. Fine. This is a job satisfaction latent score. Apply. And this is organizational commitment latent score. Apply. I can maximize from here. and maximize from here. Now, simply I will connect it. Done. I'll also connect this with this. Now, to establish the reliability of the HOC, it's a formative scale. We'll have to see its path coefficient. So I'll go and calculate bootstrapping, start the calculation. I'll go and open report, and I'll see the outer weights. Are they significant? Yes, they are significant. A little bit problem is there on HOC, job satisfaction, which is there. So job satisfaction is not affected. But same thing, let's try to confirm with the outer loading. So there are no issues in outer loading for all the three constructs, and therefore we will not delete the construct. We will move ahead now. So the reliability of HOC as it has been established, we can further proceed for checking the structural model. See, this is a stage 1 in which the reliability and validity of lower order was established. Here we have seen for HOC for the formative one. As it is a formative, we check its outer weights and outer loading. If this HOC was reflective, we would have gone for Cronbach alpha, composite reliability, and average variance extracted. Again, I'll go in open report to check the path coefficients. You can see all of them are significant. The same thing you can confirm by the confidence limit 2.5% to 97.5%. It should not include zero in it. See, there is no zero. All the numbers are from positive to positive, positive to positive, and therefore this path coefficients are significant. To get any indirect effect, which is there, I'll click on specific indirect effect. Again, I'll see the p-value. It's less than 0.05, and therefore this path coefficients are significant. I'll also check its confidence intervals bias corrected. It does not include zero in it. As the zero is not present, we will say that this path is significant. Now, the next thing which I want is R square. So, the structural model results can be reported from here, where you get co-workers affecting staying intention, HOC higher order construct affecting the co-workers, HOC affecting the staying intention. This we can see from graphical output also. All the p-values are less than 0.05, and therefore this path coefficients are significant. You can also highlight the paths, at which paths are more significant. Now to get the R square, F square of this model, we'll go and calculate PLSM algorithm, start the calculation, open the report, click on R square, and you will get the R square values. The new features of SmartPLS-4 includes that if you hover your mouse here, you are able to get R square, composite reliability, AVE of each and every endogenous construct. You will not get for exo, you will get for endo. For F square, you should click here and you will get the F square, the effect size of the endogenous construct. I'll request all my viewers to kindly refer my previous videos to understand the concept of F square, R square. Then you should click on collinearity statistics. All of them are having value less than 3, quite good. Now, what to do in case if your higher order construct is, this is endogenous. So let me first disconnect this. And now I'll connect the line. So it throws an error. Why? Because this model is in loop. HOC affecting co-workers, co-workers affecting staying intention is affecting HOC. So I'll disconnect one and I'll be able to run the model. You can see here. So co-workers affecting staying intention, staying affecting HOC. I'll open the report. Measurement reliability and validity of lower order and higher order is already established. Now we have to only worry about the structural model. Is it significant? So I'll click on path coefficients. To get the the path coefficient, to get the p-value, I'll go here, calculate, bootstrapping, start the calculation. Open the report, path coefficients. The p-values are less than 0.05 and therefore it's quite significant. So co-workers affecting staying intention, p-value less than 0.05, this path is significant. Similarly here also. Same thing I can confirm on from confidence intervals bias corrected. Let me check the specific indirect effect. Co-workers affecting the staying intention affecting higher order constant. P-value less than 0.05 and the value is 0.156. It means that this path coefficient is significant. So for more videos on SmartPLS, kindly subscribe to my channel. Please don't forget to press the like button. You can see my playlist in which I have already uploaded many videos related to SmartPLS. You can also follow me on LinkedIn and Twitter.